Welding symbols are the universal language of fabrication, allowing engineers to communicate complex instructions with clarity and precision. They bridge the gap between design and construction, ensuring every joint is welded as intended for safety and strength. Without these symbols, modern steel structures and machinery would be impossible to build efficiently. Instead of lengthy notes, symbols provide a concise, standardized way to specify weld type, size, location, and finish. This clarity prevents costly mistakes. An incorrect weld can mean structural failure or wasted resources. Mastering welding symbols is as essential for engineers as understanding materials or stress analysis. These symbols enable global collaboration. A drawing made in one country can be built in another without confusion. In this guide, we'll quickly review the basics, then dive into advanced symbols and real-world applications. You'll learn to specify complex joints, intermittent welds, and finishing requirements. By the end, you'll confidently create and interpret fabrication drawings, ensuring your designs are built exactly as you envision. Let's begin by laying the foundation for this critical engineering skill. Understanding welding symbols is not just about reading drawings, it's about building the world safely and efficiently. Whether you're new to welding or looking to refine your expertise, this journey will sharpen your design communication. Let's get started. Every welding symbol is built around a reference line, the anchor for all weld information. Instructions below the line refer to the arrow side of the joint, above to the other side. The arrow points directly to the joint needing welding, making placement unambiguous. The arrow side and other side distinction is fundamental for correct interpretation. A bent arrow indicates which member is to be prepared for a groove weld. At the opposite end, a tail is added only when extra information, like welding process or procedure, is needed. If no special notes are required, the tail is omitted. The reference line, arrow, and tail form the core structure of every welding symbol. All other details, weld type, size, length, build on this framework. Mastering these basics is essential before tackling advanced symbols. Think of this as the grammar of the welding language. With this foundation, you're ready to interpret and create effective weldment designs. Now, let's fill the framework with common weld symbols. The fillet weld, shown as a right triangle, is placed below or above the reference line to indicate the arrow or other side. Size is written to the left of the triangle, making specification quick and clear. Groove welds, like square, V, bevel, and U, are represented by distinct shapes and chosen based on material thickness and access. Their symbols also indicate depth and angle when needed. Plug, slot, spot, and seam welds have their own symbols, each tailored for specific applications. For example, a circle denotes a spot weld, a rectangle, a plug or slot weld. By combining these symbols with the reference line and arrow, engineers create precise instructions. Understanding this vocabulary ensures the right weld is chosen and clearly communicated. Mastery of these basics prevents ambiguity and ensures joints perform as designed. Let's move on to advanced features. Advanced symbols allow engineers to specify complex welds and sequences. Multiple reference lines indicate multi-step operations. Each line represents a separate weld, shown in order of execution. For example, a groove weld on the first line, followed by a back weld on the second, clarifies the sequence. Combined welds, like a groove and fillet on the same joint, are shown by stacking their symbols on the same side of the reference line. This tells the welder to perform both operations, ensuring strength and integrity. These features give designers precise control over fabrication, especially in demanding applications. Using multiple lines and combined symbols, a complete manufacturing plan fits into a single, compact symbol. This level of detail is vital for safety-critical structures. Mastering advanced features elevates your ability to design robust weldments. Next, let's see how to specify weld location and extent. Two symbols control weld extent and location: the all-around and field weld symbols. The all-around symbol, a small circle at the reference and arrow intersection, means the weld goes completely around the joint. This streamlines drawings and eliminates ambiguity, especially for round or square connections. The field weld symbol, a solid flag, indicates the weld must be made on site, not in the shop. This distinction is crucial for planning, logistics, and inspection. Shop welds are preferred, but large assemblies often require field welds at the construction site. Clear use of these symbols prevents confusion and costly delays. They ensure everyone knows where and when each weld is to be made. Properly specifying location and extent keeps projects on track and drawings clear. Not all welds are continuous. Intermittent welds save time and material while providing needed strength. Specify them by placing segment length and pitch to the right of the weld symbol, e.g., 2 to 6 means 2-inch welds every 6 inches. Staggered or aligned patterns are shown by offsetting or aligning symbols on the reference line. Contour symbols indicate the final weld shape, flat, convex, or concave. Finish symbols specify methods like grinding or machining for smoothness or aesthetics. For example, a flat contour with a G finish means the weld must be ground flush. These symbols control both the strength and appearance of the weldment. They ensure the finished product meets all design requirements. Let's apply these concepts to a real design, a heavy-duty support bracket. The bracket's I-beam is welded to a thick base plate, requiring both strength and precision. A double bevel groove weld is specified at the web, with size noted to the left of the symbol. Fillet welds reinforce the connection, shown by adding the triangle symbol to the same reference line. The all-around circle indicates the fillet weld wraps the entire I-beam profile. To ensure a flat mounting surface, a flat contour and G-finish symbol are added above the fillet weld. This single, combined symbol communicates groove and fillet welds, all-around extent, and finishing requirements. The result: clear, unambiguous instructions for a robust, precise assembly. Advanced symbols turn complex requirements into simple, actionable drawings. This is the power of mastering welding symbols. Welding symbols are standardized globally by ISO and ASME AWS. ISO 2553 uses a dashed reference line for the other side, while AWS, used in the US, uses a single solid line with above-below conventions. Knowing which standard applies is critical. Misinterpretation can lead to serious errors. The governing standard should always be stated in the drawing's title block. Engineers working internationally must be fluent in both systems. Placement rules and some symbols differ, so double-check before issuing drawings. Adhering to the correct standard ensures safety, quality, and consistency. Standards are the backbone of clear, global engineering communication. Even experts make mistakes. Misplaced symbols or arrows can cause costly errors. Always double-check symbol placement. Below the line is arrow side, above is other side. Ensure arrows point clearly to the intended joint, avoiding confusion on crowded drawings. Don't overspecify. Unnecessary details clutter drawings and confuse fabricators. Use the tail only for special instructions. Avoid redundant notes. Specify weld sizes appropriate for the application. Oversized welds waste material and cause distortion. Maintain consistency in symbol size and style throughout your drawings. Keep symbols clear of dimension lines and notes for readability. Add detail views for complex joints when needed. Stay updated with the latest AWS and ISO standards. Precision and ongoing learning are key to effective, reliable weldment design. Master the language of welding symbols and your designs will be built strong and safe.